Lesson 1. You should have your textbook in front of you, open to Chapter 2, Lesson 1, titled Planet Earth. You can also use your online textbook as a resource that could be accessed through your connected page, our StudySync link. My page looks like this, so go to the Student Edition, Chapter 2, Lesson 1. Here's what your note page looks like that you'll fill out as the classwork and or assignment for this activity. I'll go through each of the different sections and then we'll get started with you reading and getting a little bit extra information from this video. Lesson 1, Planet Earth. The essential question, how does geography influence the way people live? First section is titled Looking at Earth, and it gives you directions. What are the layers that make up the Earth? Use your textbook to complete the sentences that describe each layer. You would fill in this as you read through that section and you watch the rest of Mr. Shane's informative video to help you with that understanding. In the next section, it asks you to complete the chart with the names of Earth's 4 major physical systems. This entire lesson is all about planet Earth, so you're going to learn about the inside of the Earth, the outside of the Earth, how the Earth moves and rotates and orbits, and you'll be able to fill in that information as we go. In the next section, section 2 in our lesson today, it's all about the seasons. How does that movement of the Earth and its location to the sun create different types of seasons? You'll see here that you're going to label this what's called a concept web. So all these things relate to this main topic. You've got to find the main topic. It's going to be around June 21st, the day of year when the North Pole is tilted toward the sun. So it gives you these context clues. Look for these in your reading, and then you'll come up with what that main idea is for those concept webs. There's 1, 2, 3 of those to complete. The last section of our textbook reads about factors that influence climate. We're going to talk about the difference between weather and climate, and then what influences that climate in a specific area. There's a number of different things that we're going to go through, and you're going to be able to fill in the blank to explain how each of these factors influence climate. There are 4 of those to fill in. And the last portion, as we're talking about climate, you're going to come to recognize that different parts of the world have different climate zones. We would like to get to know what those climate zones are because they're going to show up over and over and over as we study different places in the world. So in the first column, it has listed the different types of climate zones. There are 6 of them, 1, 2, 3, 4, 5, 6. And here your task is to fill in the description. Find where it's talking about tropical climate zones and write in the description or the definition. Find where it's talking about desert and write in that portion. Hopefully that helps explain what it is expected for you during this time of reading and video watching. Chapter 2, Lesson 1, Planet Earth, can be found on page 42. Let's dive in and learn a little bit more about the Earth and its relationship with the Sun, how God uniquely created our planet and the position that it has to sustain life. Then we're going to dive inside the Earth, look at the layers, and finish up in this very first section with the physical systems that organize how our Earth can be categorized based on the physical features that we experience.
As Earth orbits the Sun, it rotates or spins on its axis. When Earth rotates, it spins in an easterly direction.
So the sun rises in the east and then sets in the west.
Earth's axis is an imaginary line that passes through the center of Earth from the North Pole to the South Pole.
People often think that the Earth stands straight up and down and spins. It's actually tilted.
The Earth makes a complete rotation around its axis in 23 hours, 56 minutes, and 4.1 seconds.
Wait, I thought there were 24 hours in a day. What about those extra few minutes? Where do those go? You ever heard of a leap year? When we have an extra day, we add those up after 4 years.
Facing the Americas, located in the eastern half of Earth, or the eastern hemisphere, Earth rotates in an easterly direction. Note that if you were looking at the western hemisphere, Earth would appear to rotate to the west, and the axis tilt would be the other direction. As the Earth rotates on its axis, different parts of the planet are in sunlight or in darkness. The part of Earth that faces the sun experiences daytime. The part facing away from the sun experiences nighttime.
If you go outside and jump up and down, the ground feels solid to you. Would you believe that the Earth is not made up of solid rock all the way to its core? Earth consists of layers, each with different characteristics. What we see on Earth's surface is only a small part of what makes up our planet. The deepest part of the Earth is called the inner core. It's about 1,500 miles in diameter. At this center of Earth is a solid core of hot iron mixed with other metals and rock. Surrounding the inner core is the next layer of Earth, called the outer core. It is about 1,400 miles thick. This layer is so hot that the metal within it has melted and is in liquid form. The temperature in the outer core can reach an incredible 8,500 degrees Fahrenheit. The mantle is about 1,770 miles thick. It is a layer of hot, dense rock. The rock moves within Earth because it is so hot it is melted. This molten rock in Earth's mantle is called magma. Magma is made up of many different minerals. During a volcanic eruption, extreme pressure can cause magma to flow to the surface of the Earth. As magma rises, it begins to cool. This cooled magma is known as lava. Lava can reach temperatures as high as 2,000 degrees Fahrenheit. Eventually, lava completely cools and hardens. It sometimes forms mountains and even island chains. After a very long time, lava can break down and release the minerals it contained as magma, creating very fertile soil. Finally, the upper layer of Earth is known as the crust. It is about 31 to 62 miles thick. The crust is a relatively thin, rocky shell and includes the continents and the ocean floors. The next time you go outside, remember that Earth is made up of far more than what you can see on the surface.
Outside of the Earth, there are other physical processes that are going on that influence the way in which we experience things in the world and the way in which life on Earth is able to actually sustain itself. There are four of these subsystems, the way in which our physical Earth operates, and they're pictured here with an example. Here you have what is called the atmosphere. The air, the clouds, the sky, everything that is above Earth's surface is considered the atmosphere. The living things on Earth are depicted right here, and this little leaf doesn't really do it justice, the creation that God has made. The living things are called the biosphere. So every plant, animal, human, all the living things would be considered the biosphere that is a part of Earth's physical systems. Those living things, they're going to require water to survive. Our planet uniquely has water, unlike any other planet in our solar system. That's called the hydrosphere. So it is a collection of all the different rivers, streams, the rain, precipitation, snow, ice caps, oceans. All those things added together are called the hydrosphere. And lastly, you have obviously the Earth and its contents, the non-living materials. We call that the lithosphere.
Seasons are the 4 periods of the year when changes occur in weather and in the length of the days. To understand why seasons occur, first take a look at Earth. Earth is tilted on its axis. The axis, or imaginary line from the North Pole to the South Pole, is based on Earth's motion as it rotates, combined with Earth's orbit around the Sun. This combined motion causes a tilt in the axis. Because of the tilt, some places on Earth get more direct sunlight than other places at the same time. The tilt of Earth's axis actually causes the changes in seasons. As Earth orbits the Sun, it remains tilted so that the axis always stays in the same position. That means that half the planet is always tilted toward the Sun, while the other half is tilted away. On about June 21st, the North Pole is tilted toward the Sun. The Northern Hemisphere is getting the direct rays of the Sun, so the Northern Hemisphere's climate is hotter than that of the Southern Hemisphere. 6 months later, when the northern hemisphere is tilted away from the sun's direct rays are striking further south. This means colder weather and winter in the northern hemisphere, but the beginning of summer in the southern hemisphere.
In the next section, we're going to take a look at the factors that influence climate. The physical features and the physical aspects of the world and how the world moves are important to understand how the climate is created in a specific area and then how people respond to that climate. First thing we're going to look at is how elevation influences climate. Next, we'll look at the different wind patterns that are on our Earth, how the ocean might influence if it's going to be warmer or colder in an area. What is the actual difference between weather and climate? We'll answer that. And then how do landforms influence the climate in a specific area? First, Mr. Shane would like to tell you a story of a time where he traveled out to Denver, Colorado and was just outside of where the Rocky Mountains started. We flew out to Denver and I'm there to visit a friend. It was 80 and 90 degrees in the middle of the day and we're in Denver, Colorado. We're not quite in the mountains, but we're right next to them. Later that day we drove up to what was Rocky Mountain National Park and we're at about 13,000 feet in elevation. It's actually right where trees stop growing because it's so cold. We went from 90 degrees to having to wear sweatshirts because it was down into the 30s and 40s. Just a little bit of a piece of information to say, as you go up in elevation, so we were down in Denver, it's a lot lower in elevation. It's called the Mile High City, so it's actually about 5,000 feet in relativity to what the sea level is. But as we went up the mountains, we went higher and higher and higher and higher into the mountains, it actually got colder and colder and colder. Now this is true anywhere that you go, in any geographic piece of mountainous range you're going to study. As you go up in the elevation, there's actually going to be a colder temperature. The air is actually thinner in this higher elevation, therefore it doesn't have the ability to retain that same heat. You go higher in elevation, it's going to be way colder. That's why you see snow caps on the tops of mountains. In Denver, it was 90 degrees, it was the middle of summer, it was warm as can be, and when we got up to the top of the mountain, we got up to that 14,000 feet, guess what? There was still snow there in the middle of the mountain. So as you go higher in elevation, that temperature is going to decrease. Higher in elevation, you have a decreased temperature. Next, let's look at what the wind patterns do and what the ocean currents do to influence climate. Wind patterns generally travel in similar directions based on how the Earth heats up and cools down. Now, here you can see in the yellow, we have this thing called a westerly. Any of these yellow arrows are going to identify how those wind patterns are going. If you see through this entire top half section in the northern hemisphere, you have the yellow arrow repeating itself, westerlies, westerlies, westerlies. That means in this section, the wind is actually blowing from this east to west, and a lot of our weather patterns come from this east to west direction. Here we are in Wisconsin. We often look to what's going on in Minnesota and further to the west to say, okay, what weather patterns are coming this way? What's the wind looking like? Where's that next snowstorm coming from? Where's that next cold front coming from? It's coming from this western direction. But if you go down a little bit south of that, closer to the equator, you're going to see this pattern show up this way. You've got eastern trade winds. These trade winds are actually going to go in this opposite direction. They're going to travel in this eastward direction in this middle portion in the tropics section. So towards the poles, the North Pole and the South Pole, you've got these western wind directions, and towards this center part of the Earth, you've got this eastern wind direction, which is then going to influence the climate in that area. Here in the Midwest, we experience whatever weather's coming from this westward direction. Because we're kind of in the middle of this massive landmass, North America, we don't experience much of what would be the influence of the ocean. But over 70% of the world's population actually lives near the coast of one of these major bodies of water, either oceans or seas, the Mediterranean here, for example, the Indian Ocean, because when these places were settled, that's where people lived because it was closer to where there would have been transportation. Over 70% of people live near bodies of water. Therefore, those bodies of water are directly going to influence the climate in those areas. For example, right down here in the Gulf of Mexico, the water's close to the equator, therefore it's going to be really, really warm. You hear about people going on vacations to these tropical areas all the time. It's really, really warm and nice, and it's this wonderful, perfect tropical type of climate that people want to enjoy. But look at this red arrow here. The red arrows on this map depict where the currents in the ocean actually move water. You've got water from this warm area going up to this northern area, this North Atlantic current, the Gulf Stream current into the North Atlantic current, right up to this area in Europe. Well, if you look at Europe in relation to the United States, it's actually a little bit further north. You'd think that the further you are away from the equator, the greater the difference is going to be in climate. So they should be relatively cold up here. But this warm ocean current, this warm ocean water comes into this area, and now those winds that are coming across here are actually going to push what that warm water is creating right into this area. So Europe actually has quite a bit warmer climate than we have right here in North America. Again, in the Midwest, we're not really influenced by the ocean unless it's something way over here in the Pacific that's pushing across. In other parts, if you're next to the ocean, whatever that ocean water is doing, if that ocean water is warmer or cooler, it can actually influence the climate in that area. If you've got cold water coming from the South Pole or from the North Pole down into these areas, you can actually have really, really cold waters. If you've got warm water from this tropical region pushing into certain regions, you're going to actually have a warmer climate because that warmer water heats up the air in that direction, and then those wind patterns carry that there. So wind can influence climate by the direction it's traveling, and then the ocean, by the temperature that it has based on where it's located in the earth, can influence the climate to heat up a place and have a relatively warmer climate, or to cool down a place and to make it relatively cooler throughout the year. Next, we try to answer the question, what is the actual difference between weather and climate? Let's look at their definitions. First, weather is the state of the atmosphere at a given time, such as during the week, a day, an afternoon, right here, right now. If you've ever checked the weather or have seen the weather forecast, they're going to tell you, hey, here's what you can expect hourly, here's what you can expect throughout the day, here's what we look to predict for the rest of the week. It's a short period of time to indicate what is actually going on outside. Climate's different. Climate is the average weather condition in a region over a longer period of time. So people often talk about these things and maybe get these things confused as if they're the same because they're talking about, well, what does the weather pattern look like? But weather is specific to this period of time. Climate is a general, what's it like during this time of the year, or what's it like all throughout the year? A lot of times people like to go to Arizona and Florida in the winter. We call those people snowbirds because they don't want to deal with the snow up here in the Midwest that we have in Wisconsin. They're looking for a place that has a better climate. Climate would be this average weather condition over a longer period of time. And in the wintertime, guess what? Their average weather in Arizona and Florida is going to be really, really nice, similar to what we would have at maybe the beginning or end of summer in the 70s or 80s, and people like to enjoy that type of specific weather, so they move there to experience it as a climate because it's going to be warmer for a longer period of time. The difference, again, is depicted in how much time you're spending on the definition here. Climate is what you expect, the average over a large period of time. Weather is what you get. Weather is right here, right now, day to day, hourly, forecast. Some of these words here describe what that looks like. What is happening right now? If you look outside and you say, okay, what's the weather like right now? That's a specific right here, right now reference. Climate is, well, what's it usually like in September? We're coming into fall. What's it usually like in fall? Weather starts to get a little bit more crisp. The leaves start to change. You got the changing of the season. Climate is this generalization of a larger period of time. Hopefully that helps clarify what's the difference between those two. Lastly, in your reading, you're going to come across the idea that landforms can actually influence climate. We've got a warm ocean that can bring warm air, and that wind that can bring warm air into an area, and it can heat something up, or obviously the opposite could happen if there's a cooler ocean current, or these prevailing winds bring that cold water or cold air into an area. It can cool a place down. But there's also a way in which a landform can actually influence how that ocean and wind influences or affects the climate in an area. This is an example of what's called a rain shadow. Here you've got this mountainous area that has these wonderful warm ocean airs and the wind coming into this land source. It actually causes the air in this area to try and go around it. These land features don't allow air to pass through it. They actually have to go around, up, over. They can't just go through. So when you're creating a different wind current, a different pattern that weather has to follow, you get different weather patterns. In this example of a rain shadow, you have warm air and you've got all sorts of moisture in the air from the warm ocean that are going to create what would be a lot of precipitation. Now, as that wind current is coming to this higher elevation and it's forcing that weather to go upwards, the clouds condense and they're going to dump out that water that they received. Sorry, here we go. And it's going to then precipitate on one side of the mountain. The warm air and a lot of moisture in the air create oftentimes a lot of precipitation. However, if that continues to go inland, those air currents, as it's showing with these arrows here, if it dumps all that water out of the clouds here, on the other side of a rain shadow, there's no water left, so it actually becomes really arid. Oftentimes when we see a mountainous area on the coast, you might have these lush, fertile areas that people can use to grow and settle, and they have all sorts of resources right next to the coast itself. But then inside of the coast, it actually is really, really arid, and there's a lot of type of desert climates in those areas because the precipitation, that natural water source, isn't getting to those places. So landforms based on if there's mountains in an area or if there's flatlands in an area, the topography of the area can also influence how those weather patterns and how that climate is going to be created in that area. Last thing that you're going to read about is the final section on the climate zones. Climate zones are regions of Earth classified by temperature, precipitation, and distance from the equator. All those factors together influence what a climate is going to look like. The further you are from the equator, a lot of times the colder it's going to be. The closer you are, the warmer it's going to be. But there's also things like how much rain do you get, precipitation, or the actual average temperature over a longer period of time. Köppen, our scientist, is given credit for identifying these specific climate zones. And the ones that we're going to primarily talk about in geography this year are as follows. You've got tropical climates, a desert climate. Humid temperate climate means that it's temperate, it's relatively nice, but it's humid more often in what would be the summer months. There's also a cold temperate climate. I'd say Wisconsin, we fall right into that middle category because our summers can be hot and humid, but our winters can be relatively cold. So we're right in between what would be those two categories. Then you've got further to the North Pole or South Pole, the polar climates. And then in specific areas where you have high mountains, because of that elevation influence, you have a high mountain climate. Now, these categories of climate zones can be broken down and have been broken down into more specific climate types, especially to label more specific areas. Here's a picture of the United States, and those 6 categories that were identified by Köppen have now been broken down into, I don't know how many colors you can count on here, specific areas that have a slightly different climate based on, through this region, the Rocky Mountains would be the physical features and elevation influencing climate, through other parts based on how far you are from the equator. Look at the southern part of the United States here, and this middle portion, and then the northern portion of the United States. Your distance from the equator is going to be a larger influence. Take a look at what that looks like on the actual coasts where there's an ocean. Maybe it's a little bit warmer where you're closer to water, or there's actually that landform, that rain shadow. There's some mountains here in California that create what would be a really great, wonderful growing area, and then actually quite a bit of desert in this southwest region in what is Nevada, California, Arizona, New Mexico. This area is actually somewhat arid because of those features. So this kind of shows all of those different climate zones in one data.